CCNA 3 version 7 midterm single area OSPF IPv4 network address translation access control list only configure router 1 switch 1 and ASBR. Router 1 switch 1 and ASBR autonomous system boundary router. The PC servers and internet cloud have been configured. PC server and cloud configured. Review PC with IP address, public PC and IP address server already configured. All device names, IP addresses, and subnet masks are on the diagram. Okay. All IP addresses, names on all three routers. Basic configurations. Okay. The switch is considered as a router because it's a layer 3 switch. So that's why the instruction says on all three routers and include the device name. Okay, open a notepad and device name is host name, enable secret class, no DNS lookup, no IP domain lookup, the banner message of the day, unauthorized access is prohibited. Unauthorized access is prohibited. All passwords encrypted. Service password dash encryption. Online console and BTY lines include line console 0, password Cisco, no timeout, no exit timeout, login synchronous, and login. The same way on BTY lines, line BTY, all lines from 0 to 15 and the same configurations. Password, no exit timeout, login synchronous, and login. Okay, and configure this on the three routers. Router 1, enter enable configure terminal. On global configuration mode, copy, paste. Very good. But the hostname is router 1, RTR-1. ASBR, enter enable configure terminal, paste. Hostname ASBR, case sensitive. The switch, enter enable configure terminal, paste SW-1. Okay, very good. ASBR configuration with proper IP addresses, descriptions, and activation for all gigabit interfaces. Okay, First on ASVR, three interfaces. Don't forget the descriptions. Okay, first gigabit 000. Okay, gigabit 000, description, connection to internet, IP address 209.168.200.106, and 29 prefix 255, 255, 255, 248. Okay, this prefix, this is a IP for host. This is the prefix. Enter, no shutdown. Now gigabit 001. Description, the connection is to router 1. Okay, you can use any description, it's only a label. The IP address is 172.16.102. Subnet mask 252. No shutdown. And gigabit 002. That description is the connection to switch SW1. IP address 172.16.100, 172.16.106, 172.16.106 prefix. 30 is 252 and no shutdown. Okay, this is the routing configuration. First, configure the IP addresses and descriptions for router 1 and for switch 1. Okay, so configure all the IP addresses on the 3 devices before to configure routing. Okay, before to configure static routing and OSPF. Okay, so here go to router 1 and configure IP addresses, descriptions, and activation or all interfaces. Go to router 1, start with gigabit 000, interface gigabit 000, the description, don't forget that, connection to ASVR. Enter the IP address. This is a IP address for host, so you can use 72.16.101, 285, 285, 285, 252. Because the prefix is 30 and no shutdown. Now gigabit 001 with this IP address, gigabit 001, description, connection to SW1, connection to the switch, the IP address 172.16.109, 252, no shutdown, gigabit 002, interface gigabit 002, the description, connection to PCA, the IP address 10.10.10.1, 285, 285, 285, 182. No shutdown. Don't forget the loopback number 5. Interface loopback 5. Description, a loopback interface. and IP address 172.16.113, prefix 252. No shutdown is not necessary because loopback 5 changed the state to up. And SW1 can configure the switch, but because it's a layer 3 switch, activate routing for IPv4. Go to the switch on global configuration mode, IP routing, and create this VLANs, VLAN 12, VLAN 12. Sorry, exit, remove the VLAN, no VLAN. I created 122. Remove no VLAN 122 and create VLAN 12 and name PCLAN. Okay, case sensitive, be careful with the names, and it's obviously a VLAN for this PC. And configure gigabit 103 with this VLAN. Exit, interface gigabit 103. Set a description, VLAN, for example, 12. Switch port mode access, switch port access, VLAN 12. Exit. Now create VLAN 13. VLAN 13. The name corp serve, name corp serve, corp dash serve. Exit. Configure gigabit 104 with this VLAN. 104 obviously for the server. 104. Description VLAN 13. Switch port mode access. Switch port access VLAN 13. Exit. Okay, and configure the switch virtual interfaces. Make switch virtual interfaces for each of the VLANs using the first IP address in their range. Okay, there are two subnets here. The first subnet for this network, for the network of PC. This is IP for the PC, IP for host for the PC. But this is another IP for the server, IP host for the server, but it's a different subnet. So you have here you have two subnets, this and this. So on the layer 3 switch, create the switch virtual interfaces, and these switch virtual interfaces are the default gateways for these subnets. Okay, click here. So switch virtual interfaces for each VLAN using the first IP address in their range. So start with VLAN 12, interface VLAN 12. You can set a description. You can say that this default gateway for VLAN 12. Set the first IP address. Okay, according this IP of host and this prefix, the network address is 10.10.12.200 224. 10, 10, 12, 224. So the first IP address is 10, 10, 12, 225. 10, 10, 12, 225, and prefix 28, 255, 255, 255 to 40. Okay, no shutdown is not necessary because VLAN 12 changed state to out. Now, VLAN 13, interface VLAN 13, the description, the default gateway for VLAN 13, and the IP address. Okay, according this IP of host and this prefix, the network address is 10.10.13.128. The network address is 10.10.13.128. So the first IP is 10.10.13.129. IP address 10.10.13.129. And the prefix is 27, that is 224. Enter. Exit. Gigabit 101 and 102 are layer 3 interfaces. Okay, proper IP addresses, descriptions, and activations. Okay, and Gigabit 101, interface Gigabit 101, description. The description is the connection to ASVR. The IP layer 3 port, no switch port. And the description and the IP address 100.5 prefix 30. .5 prefix 30. 172.16.105 prefix 30. 105 prefix 30. Enter. Okay, no shutdown is not necessary. Change it state to up. Now, Gigabit 102, IP address 10, prefix 30. 102. Description is the connection to router 1. No switch port. IP address 172.100.10. 10 prefix 30. Exit. And now continue with OSPF. So go back to ASVR and configure the static and dynamic routing. On ASVR, go to ASVR and create a default route to internet using the exit interface. This is internet, the exit interface is Gigabit 000. Exit default route, IP route, Gigabit 000. Don't worry about this message. Now configure OSPF, process ID 10, router OSPF 10, router ID 1, router-ID 1, area 0. The reference bandwidth should be 10,000, 4 zeros, autocost reference bandwidth 10,000. Ensure the reference bandwidth is consistent across all routers. So configure this on all routers. Passive interface for the link to internet. Okay, on internet you don't have a OSPF network, so gigabit 000 should be passive. Passive dash interface gigabit 000. Tell the other routers about the default route. So redistribute the default static routes. Default dash information originates. Okay. Network statements should be applied on the two internal interfaces. Okay, one network here and another network here. So do the following: do show IP route connected to view the directly connected networks. You have three. This is for the internet. Only advertise these two networks. Network 172.16.100.0. The wildcard for 30 is 3 and placed on area 0. Remember, it's area 0. And this another. Same wildcard area 0. The links to router 1 and switch 1 are OSPF point-to-point. Okay, exit from router configuration mode and global configuration mode. Connection to router 1 is gigabit 001. Interface gigabit 001. IP OSPF network point-to-point. Enter. And connection to the switch gigabit 002. The same command exit. Now, configure access control lists and network address translation at the end. So continue with router 1 with OSPF. Go to router 1, process ID 10, router OSPF 10, router ID 2, router-ID 2, area 0, reference bandwidth 10,000, auto-cost, reference-bandwidth 10,000. Okay, very good. And passive interface, the loopback and PC LAN. Okay, passive interface, this interface gigabit 002, because you don't have an OSPF network here. And obviously on the loopback, okay, router 1, passive dash interface gigabit 002 and loopback 5. And 4 network statements, and should be the exact IP address of the interfaces. So use the IP address of the interfaces, the IP for hosts. Okay. And network, use this IP, the IP of the interface 172.16.101 and 72.16.101. The prefix is 30. So use wildcard for 30, that is 3, and area 0. Now, this another is number 930. 9 wildcard area 0. This another 10 10 10 1 26 network 10 10 10 1. The wildcard for 26 is 63 area 0. Okay, for 26 the wildcard is 63. Enter 3 network statements. You need 4 network statements in the loopback. 13 prefix 30. 172.16.113 prefix wildcard 3 area 0. Okay, the links to ASVR and switch 1 are OSPF point to point. Okay, exit. Interface gigabit 00 should be point to point. The connection to ASVR. Interface gigabit 000 IP OSPF network point-2 point. Okay, look at this, the neighbor adjacency with ASVR, very good. And another interface gigabit 001, the connection to SW1 should be point to point gigabit 001 IP OSPF network point to point. That's it. Okay, no neighbor adjacency because you need to configure OSPF on the switch. So continue with switch with OSPF configuration. Go to the switch, process ID 10, router OSPF 10, router ID 3, router-ID 3, area 0, reference bandwidth 10,000, auto cost reference-bandwidth 10,000. Okay, very good. Passive interface for the 2 switch virtual interfaces. Passive interface. Okay, remember the switch virtual interfaces are the interfaces for VLAN 12 and 13. VLAN 12 and 13. 4 network statements should be the network addresses of the interfaces. Okay, and to view the network addresses, use do show IP route connected, and you can see 4 network statements with the network addresses. So use network addresses. Network wildcard for 28 is 15, AS0, 10, 10, 12, 224, 15, AS0. The next is 10, 10, 13, 128. Wildcard for 27 is 31, area 0. And the network 172.16.104. Wildcard for 30 is 3 and area 0. Okay, and continue the last number 8. Number 8, same wildcard area 0. Enter. And the links to ASVR and router 1 point to point. Use this interface to ASVR gigabit 101. Exit interface gigabit 101. IP OSPF or SPF network point to point. Okay, look at this, the neighbor adjacency with ASVR. The another interface to router 1 is gigabit 102. 102. Okay, enter. IP OSPF network point to point. Okay, the neighbor adjacency with router 1 on this side. Exit. So you can verify OSPF. For example, on router 1, and show IP route. Now you can see the directly connected networks with 3 OSPF networks. This network is this. This OSPF is 12.224. Is this another 13.128? Is this? This directly connected network is this OSPF 104. Is this directly connected network 8 and 12. Directly connected network 8 and 12 for the loopback. But I don't have the static route propagated or redistributed by the ASVR router. Go to ASVR and show running config, enter space. This static default route should be redistributed by this command on OSPF, and this default static route should be redistributed to the other routers, and router 1 should have the default static route, and I don't have that. Do the following: copy running config to startup config to save changes, enter, reload, enter. Go to ASVR, copy running config to startup config, enter. Copy running config to startup config, enter, reload, enter. On the switch the same way, and copy running config to startup config, enter, reload, enter. And wait a moment. Okay, go again to router 1, enter. Remember the console password is Cisco. Enable. The enabled password is class and show IP route. Now you can see the directly connected networks with letter C, the OSPF networks with letter O, with the OSPF external type 2, OSPF external type 2. Is the network. This is internet. So from PCA, click on PCA, ping internet 50 50 52, ping to 50 50 52. Okay, ping fails, but you need NAT configuration on ASVR here to permit the connection to internet. So don't worry about this. So ping to PCB, ping to PCB. Success, repeat, success, and ping to the server. Success, very good. And now, okay, now configure the access list, NAT access lists, and on ASVR access list number 1, go to ASVR, two-line extended access list named allow valid SRC source. Okay, two-line. Name it, enter, and Cisco enable class configure terminal IP access list extended. Okay, extended, name it, and use this name case sensitive. Allow valid source SRT. Be careful with the names. Enter. Allow IP traffic from the outside address range. Use this range. Allow is permit IP traffic. Permit IP traffic. Permit IP. The source is outside address range. Use this range. Okay, 209.165.200. 104 prefix 29. Okay, this is a network address. You can calculate this is not a host address. This is a network address. So you can allow all the range 209, 165, 200, 104. The wildcard for 29 is 7. Okay, and permit IP. This is the source. Okay, allow IP traffic from the outside address range to the internet. So the destination is internet, and internet is any. Okay, so only packets that have been properly NATed. Okay, this is the range of IP addresses that will be used for the network address translation. And you will permit these addresses because they are the source and any is the destination is internet. Enter. Deny all other traffic. Deny IP from any to any. Apply outbound on the interface to the internet. The interface to the internet is gigabit 000. Interface and exit. Interface gigabit 000 IP access group. Use this name. Allow valid SRC. Be careful with the name and outbound. Out. enter and exit. Okay, very good. The access list number 1 on ASVR is 2-line. Okay, so you need 2 lines, 2 entries, so it's very good. Now we continue with access list number 2 on ASVR. On ASVR, 3-line standard access list named not this. IP access list standard. Okay, a standard named not this. So use not this. Okay, IP access list standard not this. Enter. Allow this range of IP addresses for these networks with number 10 ASVR. Permit, if it's standard, use only the source address 10 10 0 0. Wildcard for 16 is this. Enter. This another for the networks with number 172, like these networks with number 172. Permit 172 16 100 0 100 0. Wildcard for 240. The wildcard is 15. Enter. Deny all others, deny any. Okay, 3-line, 3 entries. And do not apply to any interface used in the NAT configuration. And now configure NAT. Okay, exit. Assign proper NAT inside and outside designations on the gigabit interfaces. Okay, this is outside because it goes to internet gigabit 000. For gigabit 000, IP NAT outside. Gigabit 001 and gigabit 002 inside. Gigabit 001 inside. Gigabit 002 inside. Exit. And static NAT for inside address 172.16.113, and here's the loopback 172.16.113, and the outside address 209.165.200.109. Okay, it's a static NAT, IP NAT inside source static. The private IP 172.16.113, and the public address 209.165.200.109. Enter. Pool, name it NAT pool, IP NAT pool. Use this name NAT-pool, case sensitive NAT-pool. For this range of addresses from 107 to 108, 209, 165, 200, 107 to 209, 165, 200, 108, 107 to 108. Using netmask keyword, use netmask. But what is the netmask? What is the subnet mask? So the netmask is the netmask of the exit interface. The network here is the network address here is 104.104. The first is 105 that is configured for the cloud. The second is 106 for this interface on ASVR. The next is 107 for the pool. The next is 108 for the pool. And the next is 109 for the static NAT. So use this prefix 29, 285, 285, 285, 248. Use path or dynamic NAT with the pool and overloads. Okay, so IP NAT inside source list. The list that will be permitted for NAT is this, not this. Not this, be careful. This. And the pool is this. Use these IP addresses for the translation. The pool is not pool. Not pool. Not this list, not this, pool, not pool. And don't forget overload for port address translation path. Enter. Interface is configured. Very good. Now you can test the translation. Go to PCA, ping internet 505052. Success. Go to ASVR and show IP NAT translation. Now this inside global is the public IP address. This IP is the IP of PCA and is translated to this public IP address, and this outside local and global the IP address of public PC. And from public PC ping to loopback 5 using the public IP address. Go to public PC and ping the static NAT. Ping the loopback but using the public IP 209.165.200.109. 209.165.200.109. Success. Go to ASVR, repeat, show IP NAT translation. Now you can see this is the IP address of the loopback 5. This is the public IP of loopback 5 and the IP addresses of public PC. Finally, on router 1, no access control lists, and switch 1 access control lists. Go to switch 1, enter password Cisco, enable password class, configure terminal, create a 3-line extended access control list. Okay, IP access dash list extended using the first available extended access list number. The first available number for an extended access list is 100. It's not 101, it's 100. Okay, 100. IP access list extended 100, or simply use access list 100. Okay, extended access list 100. And on the first line, don't allow non-secure web traffic from the entire PCB LAN. Okay, PCB LAN. to the server, to the server. Okay, don't allow non-secure when traffic. Don't allow is deny. So deny non-secure web. Non-secure web uses TCP protocol, deny TCP. Okay, so the source is from the entire PCB LAN or the network of PCB. The network is 10, 10, 12, 224. 10, 10, 12, 224. And the wildcard for 28. The wildcard for 28 is 15. Okay, and the destination is a host. Use the host keyword and the IP address of the server. The destination is only a host, it's not a network. Host 10.10.13.150, the IP of the host. 10.10.13.150. And non-secure web traffic is port 80, that is web. Okay, review access list 100, the TCP to this host. Okay, the prefix, another prefix. You don't need a prefix here, and okay, enter. The next, don't allow secure web traffic from the entire PCB LAN to the host to the server. Okay, so it's basically is the same entry. The only difference is this is secure web, so it's the same, but the port for secure web is 443, and all is the same. The entire PCB, the entire LAN of PCB is the source, the destination is the host, is the server, secure web is this port. Okay, enter. And allow all other traffic. Access list 100, permit IP from any to any. Apply the access list where it will be the most effective. Use best practices. Okay, this is the source. This network is the source. This is the source. And the destination is this host. Only the host is the destination. And draw a line from the source to the destination. Okay, and it is recommended to apply an extended access list. Apply extended access list. Apply extended access list close to the source. okay, close to the source, and should be applied on this interface. On this interface, okay, here, on this interface, and is incoming traffic. You can see the arrow is incoming traffic on this interface. Okay, incoming traffic on gigabit 103. Interface gigabit 103 IP access group. This 100 incoming traffic. Enter. IP. Okay, and this is not permitted because I made a mistake. You should apply on the switch virtual interface. No, in this interface is a layer 2 interface. You need to apply on the switch virtual interface, and for this is interface VLAN 12. Interface VLAN 12 and IP access group 100 incoming traffic. Enter. Next. You can verify PCB pinged to the server 10, 10, 13, 150, success. Okay, this is very good, but web traffic is not permitted to the server 10, 10, 15, 150. Enter. Request timeout, very good. HTTP is non-secure, but HTTPS is secure. Go. Okay, and web traffic is not permitted, so access list is working very good. Then apply access list. Access list number 2, create two-line standard access list using the last available standard access list number. Okay, also on switch 1, access list, the last number for a standard access list is 99. Allow host PCB. Okay, permit host PCB 10, 10, 12, 230, 10, 10, 12, 230. Enter. Deny all others. Access list 99. Deny any. Apply this access list to the BTY lines inbound. Okay, on all BTY lines, line BTY from 0 to 15. Sorry, line BTY from 0 to 15. Access class. Okay, it's not access group, it's access class. Number 99 incoming traffic. Exit. So only PCB can use the telnet access to the switch. Okay, for example, go to PCA and try to use the telnet client, this telnet client, and try to access the switch using this IP, for example, using telnet 172.16.110, connect. The current session has closed. Okay, so it's not permitted for PCA, but will be permitted for PCB. Go to PCB, close this, the telnet client, telnet. Use, for example, the default gateway is 10, 10, 12, 225. Connect. Password is Cisco, and very nice. Exit. No. So access list is working very good. And check results. Okay, and 95%. Okay, all is working very good. And don't worry about the 95%. Thank you very much.